-5 in the y, which would put us to here. So that's our start point, and then the end of the domain is +5 in the x and +5 in the y. So that's how we're ending up at this point here. And the reason why we want to use an expression is because we don't want to put in the values -5 and 5, or at least I don't want to, because I don't really care about half the size of the square. I want to know, I want to put in the value that is the full dimension of the square. So the full dimension is 10 by 10 millimeters. So it's up to you how you want to go about that, but that's my strategy for generating squares when I want to generate them from the center point. And if we don't want to generate from the center point, let's just use this grid to understand how we would generate a rectangle or a square that where we want to control both the start point and the end point. Okay, I'm gonna make some new components. So if we want full control of our rectangle, we have to generate 4 sliders and two domain components, which is why in the last example I was using an expression to simplify this process. But if you need full control, you can do something like this. So I've changed the sliders to go from -10 to +10, and now we can start, and if we want to generate the same square that we had before, we would make our x domain go -5 to +5, and our y domain does the same thing, -5 to +5. And now you can see why I set it up like I did in the last example, a lot cleaner, a lot more efficient. But this example gives us full control of where a rectangle ends up in the coordinate system. So if we want to change just one value, we can change the x value, and we can change the y value. And now, even though our origin of the plane that we're using is still at the x and y, the rectangle is not limited to where that origin is, because we have full control of the start and the end points. Okay, so if we look at our x value, our first x value, it's -3, so it's right here, 1, 2, 3, and we can see it lines up right there. And then our ending x value, our b value, is at 5 right there. And then same with the y, so -1 is where we're starting, and it's ending up right there, and +3 is where it's ending. And so that's the basics of how we're using domains to construct rectangles. And that's where we're going to end it for this video. And let me know if I missed any any fundamental things to do with domains. So we looked at how we use domains to generate sublists. We looked at how we use domains to remap numbers. And remember, we are going to get more into this very soon, because this can become a pretty complex topic. And we looked at how we use domains to generate rectangles and squares. So let me know if that helped, and I'll see you guys in the next video. Take care.
Welcome, everybody. Welcome to the very first Grasshopper Fundamentals video. This is going to be all about basically how to operate, what the fundamentals of operating Grasshopper are. Okay. We're going to obviously be going into a lot more depth in later videos. Okay, where we covered Rhino in the last video. We just talked about the Rhino interface in the last video. This time we're going to talk about the Grasshopper interface, and later on we're going to go into depth into the components, and then we're going to go really in depth into the fundamentals of systems thinking. Okay, but let's not get ahead of ourselves. We got to figure out how the heck are we supposed to operate this thing. Everyone's talking about Grasshopper. Parametric Phil, he keeps talking about Grasshopper. How the heck do we operate this thing? I'm going to tell you. Just have some patience. Have a little bit of patience, okay? Thank you. Okay. So, where do we start? Let's think. Okay. I'm going to start off. So basically, we're going to cover everything that you can see with your eyes here. But I just want to kind of set up how we're supposed to think about operating in Grasshopper. So first of all, you already know how to operate in Rhino, I think. And if you don't, you can go back, check out my Rhino videos on YouTube or on this website. And so we're going to open up Grasshopper like this. We're going to launch Grasshopper. It's going to open up. We can see some recent files, or we can start a new script on this canvas. So this is called the canvas, okay? Because the canvas is where we can drop our components, okay? What the heck is a component, Phil? I'll tell you. A component, we can think about a component the same way that we think about a command, okay? So let's build a box in Rhino, and then I'm gonna do the same thing in Grasshopper, and we're gonna see how this Grasshopper concept is working, okay? So first I'm gonna draw a rectangle, and now here's my example. We're gonna talk about extrude. So you might have seen already that basically this is an extrude component. So keep that in mind, okay? Right now we're gonna do the extrude command though, and I'm gonna show you. We can think about components the same way that we're thinking about commands. So let's do the extrude command. We're gonna do the extrude curve, okay? And when we do extrude curve, look at what it says. It says, Phil, select curves to extrude. So I'm saying, okay, all right, Rhino, you want some curves to extrude? I'll give you this curve. I want you to extrude this curve. That's an input. So basically, I just gave Rhino a data input. This curve is the data that's required in order to make the extrusion. Okay, it's the base profile. Okay, and now that we've selected the curves, we can hit enter, and now we can start building our box. And now we come to a second data input, which is basically the height of my mouse, the height that I place my mouse, or the number that I type in. It could be the height of my mouse or the number I type in. Either way, we have to define a second data input. So again, the first data input, select curves to extrude. Okay. Yes, I want these curves to be extruded. That's the first data input. Enter. The second data input, what is the height? Okay, so 100. That's what I want. That's what I want, Rhino. Okay. 100. Enter. Now we have a box. Okay. Now, with Rhino, we don't have access to that original. I can't change that original rectangle. I can modify the resulting box, but I can't necessarily modify that rectangle and have the box change. Watch this. See, I'm modifying the rectangle, but the box is not changing. Even though I made the box using this reference data. This is the first item. This is the first data entry that I put into this extrusion process. But if I modify the original data item, it does not affect this box. This is because Rhino is not a parametric system. So let's go back into Grasshopper. And let's look at how things are a bit different in Grasshopper. Fundamentally, there are a lot of similarities, but there are also going to be a lot of differences. Okay, so our component, we're on our canvas. We want to extrude. We want to go through the extrusion process. Now, don't worry, I'm going to explain a lot of the other stuff that's going on here, but I just first want to basically lay out the fundamentals of what's going on in Grasshopper. Extrude. So we double click on the canvas. Double click on the canvas. We type in extrude. You're going to get used to, what's the proper extrude. We don't have extrude curve like we do in Rhino. We're just going to use extrude. So now what do we do? Now this component looks angry. It's all orange. It's angry at us. It's got this little flag. We don't have the sufficient data to execute this task, basically. Okay, it's telling us which input parameters do not have the sufficient data, and that's input B and D. So both of them are empty. Okay, so first of all, what we can do is we can hover over the center, and it will tell us the name, it will tell us the nickname, and it will also give us a little description. It's saying extrude curves and surfaces along a vector. That sounds good. That sounds cool. And then, but how do we operate this? Okay, we're gonna hover over the inputs. These two are the inputs. This is the outputs. Okay, this is an input. This is the base. Okay, so it requires a base. We need a profile curve or a surface. And that little hexagon with the swirl thing that looks like it's trying to hypnotize you, it's basically, that's a symbol for a curve or a surface. Okay, and so it's just an easy way to identify what is required as the input. Over here on the D is often stands for direction. Again, it's asking for an extrusion direction, and again the hexagon this time it has an arrow, and that's just a short form. It's an icon asking for a vector. Okay, so basically we have to understand what the inputs are in order for the component to do its main job, which is outlined when we hover over the center, and then it's going to tell us what the extrusion what the output is. It's going to tell us what the result is. This is the output. So we have our inputs, we have our main the main work of this component, and we have our outputs. But let's go back to Rhino. Look at this. Extrude curve. This is an input. Select curves to extrude. This is an input, a data input. Enter. Okay. Extrusion distance 100. This is a data input. Okay. Enter. This is a data output. This is what was outputted from the extrusion command calculation. Okay, to see what's going on here. Fundamentally, it's the same process. So, but the difference is we have access to all of the decisions that we're making in Grasshopper at all times. Okay, so how do we input a profile curve or surface into this component? Well, there's many ways that we can do that, but just to start out with it, let's just grab a very simple curve parameter. Okay, so I'm going to type in curve, and this is a curve parameter, and you'll find all your parameters in the very first category here. Anything that is a hexagon is basically a component for us to input our some type of geometry or some type of data from Rhino, and parameters is very simple. It's just a container. We can think about it like a container for some type of geometry or data or geometric data. Okay, lots of different options here. Okay, and then we also have the ability to use these containers for numbers, text, colors, times, okay, file paths. So that's what these hexagons are doing there. It's basically defining that it's a parameter. Okay, so now that we have this curve parameter, we can see the inputs in the outputs are a lot more simple than most components. They don't have these letters because they basically just you just input a curve and export and it outputs a curve. Okay, it doesn't really do any calculation. So we can hover over this and 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 what we can do is we can either create a curve in Grasshopper, but for now we're just going to take this curve out of Rhino. We're going to plug it into Grasshopper. Okay, so we're going to hover over this thing. We're going to do right click with our mouse, and we have some options here. And we're going to ignore most of these options for now, and this is something that we'll get into later. But what we're going to choose is set one curve. Set one curve, okay? We've already selected the curve in Rhino. So once we do set one curve, it's going to grab that curve. It's going to throw it into this parameter. Alternatively, we could have done set one curve, and now in Rhino, it's saying, what curve do you want to use, bro? And I'm going to say, I want to use this curve, okay? So now we have that curve, and we can tell that because when we click on our parameter, it highlights in green, okay? That's giving us a preview of what's inside this parameter. So now we have a curve in the Grasshopper canvas. And what that means is that this component wants an input. It wants an input of a curve, and this is a curve. So all we have to do is connect it with this wire. Boom. So now we've input this curve into this component. We've gone from this output to this input. That's the fundamentally that's how Grasshopper works. So now it's still not working. Why isn't it working? Well, we go to our flag here, and then you can see we have one less issue, but we still don't have enough data for the D input to execute our task, our component. So what the D needs is a vector. Now let's think about that. In Rhino, it wants a vector. By default, Rhino is choosing the Z vector, and then we're just typing in the units of our vector. But that's not always the case because we can change the direction. We could change the direction. We could make it, I don't know. We could make it go in this direction. So that's a different vector direction, and we can still type in the units. We can still type in 50 units. Okay. So basically, we're defining a vector in Rhino, but we're not really thinking about it that way. But we're always defining a vector when we're doing some kind of operation like this. It's the same thing in Grasshopper. Okay. A vector again. A vector is a direction and an amplitude. Okay, so first we can select a direction. And what we'll do is we'll grab a unit vector. So lots of different ways to do it, but for now we're going to grab a unit vector, unit Z. So a unit vector basically, once we plug this in, it's going to make a unit vector has a factor of 1, so it's 0, 0, 1 because it's a Z vector, a Z unit, so it's 0, 0, 1. So it's just going to go 1 millimeter up. So it's already working. Actually, we don't have that orange flag anymore. This component is not angry at us anymore. It's gone gray because it's not orange anymore. It's not angry. We're good. And but right now it's only 1 unit, and we want it to be 100 units. So we need to change the factor. Okay. So again, we're kind of going backwards in the script. Kind of reverse engineering how we want this thing to work. So now we're looking at, now that we solved this, we gave this the input that we wanted. It wanted a vector. We gave it a vector. We went from the vector output into the vector input over here. But now we actually need to change the factor. So we're looking at this input, and see the hexagon right there? It's asking for a number because the hexagon with 0.01, that's an icon for a number. And it's asking for a unit multiplication. So what we can do with that is we can plug in a slider, and there's a lot of different ways that we can activate a slider. We can just type in slider if you want. Slider is going to, by default, it's going to be 0 to 1 with 3 decimal places. We have a lot of control over that with 2 ways. We can either double click, and we can change the slider parameters in here. We can make them rounding to integer numbers, even numbers, odd numbers. We can change the number of decimal places. We can change the minimum and the maximum. And we can change the range, okay? But I would rather just create the slider the way that I want to from the start. So instead of having to go into that menu, if I can avoid it. So what I'm gonna do is type. I would say I don't want any box that's smaller than 25. This is just an arbitrary example. I don't want any box that's smaller than 25. So I'm gonna first type in 25, and then I'm gonna do dot dot, and that means we're going to the next number. We're going to the max. 25 is the min. And then we're going dot dot. Let's go to the max. And now I think I want the max to be 200. I don't think I'm gonna make a box that's any bigger than 200. And I want a resolution that's 1 decimal place. So the min is 25, dot dot, the max is 200, and then we're going to put in 0.0 to activate a resolution of 1 decimal place. When we hit enter, now we have 25 to 200 with a resolution of 1 decimal place. We can either slide like this, but if we hold control, we will be able to slide one unit at a time. You have a lot more control over the slider that way. So again, hold control, you have more control. Interesting. So the slider as an output. The slider is going to output whatever number is showing up on the slider. So we can use a wire. We could plug it into the factor. Whoa! Holy cow. Okay. It's crazy. There we go. So now we have a box. Okay, and now we can change that that vector factor with this slider. Super cool. We can also, unlike in Rhino, we can also change this original curve, and the extrusion will automatically update. So that's interesting. So you can see that we actually have all different parameters available to us at once, right? If we go further, if we take this further, we can do a mirror. We can plug in the output. This is the output. We can click on it to preview that the thing in green is the output of this component. We're going output. We have an extrusion. The mirror component, it needs a base geometry, which means any type of curve or surface. So we go from the extrude component to the mirror component. We need a plane of some type. Now, I can input a plane. Oh, it's already defaulting to the x to the YZ plane. So it's already by default putting the YZ plane, and that's why we're not getting the little flag that says, "Hey man, we need some more data." We're not getting that flag because it has a default. So some components will come with default inputs, some won't. So this one has a default. We can choose either to change the plane. I can say no. I want a XZ plane, and then it's gonna change that plane. It's gonna put it there. Okay, so we can do an input like that, and we can also create a plane using some type of parametric routine, which is something that we'll get into later. But let's say that you just want to do it really quick. Just want to get it over with. You want to do it really quick. You want to do it as if you're modeling it in Rhino, and I'm just going like this. I have this object, and I want to mirror it, and I want to mirror it right here. And then get this object over here. Let's say you want it to be that simple. Okay, I'll show you. We have our original object. We have our mirror plane. Sorry, we have our mirror component in our output. What we can do is right-click it. Okay, right-click, set one plane, and now we can click the origin of our plane, and then we need to make sure that we're typing in our x-axis, our y-axis. Okay, and now it's underground. Okay, so what we would want to do to mimic what we did in Rhino is set one plane, and what we're gonna do is set our origin here, and we're gonna have to make it vertical like this. And now we have our mirrored object, just like we did in Rhino. Now the way I did that was the origin, and then I went back to the origin. I'm holding Control so that I can type in a point that's vertical to the last point that I clicked. Okay, holding Control makes our cursor go vertical. And then I'm defining my x-axis, my y-axis of this plane, and that's how we're ending up with that object. So anyways, the point is, now that we have a sort of a string of different components, we can think of them kind of like commands, but all of our parameters are available to us at any time, right? Now that we have this string of components, now we can modify this, and everything else will modify accordingly, because it's starting here, it's going through here, it's going to here, okay? And both of these will modify, this factor will modify both of them. I think you see what's going on. I think you're picking it up. So that's kind of the fundamentally how this whole operation is working, okay? We have our inputs, we're checking what our inputs are, we're trying to figure out what components we need to put on the canvas in order to achieve those inputs. There's kind of an infinite number of different ways that we can achieve those inputs, right? I can create a panel instead of a slider, and I can just type in 95 if I want to do it that way. And now I have the same thing. It's not as it may not be efficient because I can't slide it. I can also generate a number parameter, and I can input the number into there. I can type in 95 like that. Okay. It's all achieving the same result. It just depends on the context. Depends on what's the most appropriate. Maybe you're trying to save space. Okay. Let me actually turn on bifocals here. Here we go. Now you can see the names of these components. I like to use icons. Okay, let me show you that right now. I like to use icons because they save a lot of space, and the brain really locks onto icons a lot more than with text. But but we can also choose to turn on the full names. Oops, not that one. This one. Oops, not that one. This one. There we go. Now has these like short form names. Extrude, mirror. That's your choice if you want to do that. I prefer not to, because the components are always become larger. Everything becomes black. There's no color. There's no shapes. I like using the icons because my brain can pick it up a lot faster when you have a script with hundreds of components. This becomes, I think, a lot more efficient. But we can use bifocals, which doesn't come with Grasshopper natively. But you can download bifocals, and with bifocals we can see the icons, and I can put the names of the icons above the components. So I'll probably be doing that in most of my tutorials for you guys. Okay. So that is the fundamentals of how Grasshopper is operating. Now let's just spend a few minutes to talk about some of the stuff that's going on around the rest of this interface. Okay. We have our previews. Okay. Our preview, the curve is being previewed here. The original extrusion, the mirror. We can turn the preview off like this. Turn the preview on like this. We can also turn off all the previews like that. Okay. Or we can turn on wireframe preview. Okay. We have some display options, like this one will only allow the selected object to be previewed. These are some document settings. You can change the color of your normal objects and your selected objects. You have some quality options to change maybe how well the computer is going to refresh your geometry. If you have a powerful enough graphics card, you can leave it on high. If not, you want to leave it on low quality. Okay. Now what's going on up here? Now this is where all of our components reside. I talked about the parameters, of course. Again, anything with the hexagon, some type of parameter where we can input geometry or some type of geometric data. We in the rest of the parameters we have some. This is where we found our number slider actually, and a lot of other inputs that we can use. These are kind of like the interactive um, interactive parts of the script, like this button. You can turn a button on and off. It's kind of fun. We have a knob. Woo wee. Okay. We have like colors and stuff like that. And if we go through these, you can see that the components are changing a lot. So we have different things like mathematical components, operators, polynomials. We have some scripting components, and you're gonna get used to, you know, if you don't know what the component is called, you're gonna get used to kind of figuring out where you're supposed to look for them. This is where you're gonna find all of your set components for like data management, list management, list organization, list modification, stuff like that, grafting, some tree modification components. So again, you can double click, you can look it up that way, or you can go through the tabs and you can find all your components that way, and then you can click here to open up all of them in this kind of subcategory. Now you'll notice that I probably have a lot more tabs here than you do. So all of the basic tabs are here. We have vector, curve, surface, mesh, intersect, transform, display. The user tab, you may not even have that yet. That's if you're making custom clusters and you're turning your clusters into components, which is something we'll talk about later. And everything else, this is stuff that I've downloaded from Food for Rhino. Okay, Food for Rhino is an amazing resource for Grasshopper users. This is where you can download these add-ons. So I have a bunch of add-ons. There are literally hundreds or thousands of add-ons. I'm not sure. That can do some pretty crazy stuff. This is something, for example, that I used when I was in building science school, where this is something we can use to calculate weather data. We can calculate. There's environmental analysis tools. There's data we can use to calculate the energy efficiency of buildings, the thermal efficiency of walls, some crazy stuff like that with Ladybug. We have other things. We have pufferfish, which is, I believe, developed by a brilliant guy that works in the computational design department at Nike, and this has a lot of great components for surface modeling and stuff like that. We have things like Kangaroo, which is a physics engine, basically. We can simulate a lot of different kind of interesting physics models. Okay, we have stuff like MetaHopper, which is actually kind of like Grasshopper for Grasshopper because it can control things on the canvas. Anyways, you can look through Food for Rhino, and I guarantee you're gonna have to download an add-on eventually because you're gonna want to. There's a lot of crazy stuff out there. I'm using these add-ons all the time, for sure. Okay. And so that is the basics of what's going on in Grasshopper. I don't think I've missed too much. You have obviously your tabs here with some other options. Okay, I think I've actually covered most of the stuff I wanted to cover in the basics. Actually, one more thing I should mention is that if you want to get a preview of what's going on in the output, just open up a panel. And the way that we can do that is you can type in panel if you want, but I would just type in quotation mark, one single quotation mark, press enter. Now you have a panel. You can type stuff in that panel, but you can also use the panel to preview what's coming out of your component, like this. We have an open brep coming out of this component. Interesting. We have an open brep coming out of this component. What's over here? That's a vector. Interesting, right? That's actually a vector. What's coming over here? That's like just a number, okay? And we have a curve here. So open up your panel. I kind of use a panel like this. It's just like a tool for me to actually see what the heck's going on. I'm using the panels all the time. All the time. Like almost 100% of the time I have a panel near me to see what the heck is going on inside these components when I'm changing stuff. When I need to see what am I going to use after this? Well, I have to see what's in there. Is an open brep. Right now it's obvious, but sometimes we're going to have hundreds of different objects and they may not all be open breps. Maybe they're grafted in a certain way. We need to look at the data management. Anyways, we'll get into that stuff later. But I think I'm going to wrap up this introduction. Let me know what you think. I hope you're looking forward to the rest of the videos as much as I am, because I'm super excited to be making these videos. This is so much fun. The next videos are probably going to be getting into the more specifics about these components. I'm going to try to make a video for every single one of these components. Is it possible? I don't know. We'll see. But I'm definitely going to do the basic ones. No, I'll do all of them. Eventually. Eventually, I'll get through all of them. But first of all, I'm going to explain just the details of everything that's going on in here, in this menu, so make sure to check out my next videos. Alright? Hope you enjoyed. Hope you learned. I'll see you in the next video. Peace. Alright, welcome back everybody to Grasshopper Fundamentals. In this video, we're going to do a basic overview of how components work and how to operate them. So what we're going to do is we're going to go through, we're going to talk about the components up here in these menus. We're just going to kind of cover generally how these categories are working. We're also going to talk about the component themselves. We're going to talk about the menus that we're going to find in the main part of the components and in the center part of the components. These are the right-click menus, and they're a little bit different depending on which component you're selecting. We're also going to talk about different types of data streams. We have different data types that are going between different components, and it's really important to be aware of those different types of data. And we're also going to talk about what these warning flags are. Okay, we have a few different flag types. Okay, so in one of the previous videos, I talked kind of conceptually about how inputs and outputs work. So you're going to want to check that out if you haven't seen it already. And I talk about how we can think about data inputs and outputs and how it relates to our knowledge of working in Rhino. And so this time we're going to go a little bit more in depth into actually how to operate a component. Okay. So first of all, you might already know we have these tabs up here, and we have different categories that, like I said, we're going to talk briefly about this closer to the end of the video. And then we have these subcategories that we can go into. And then in the subcategory, we can click on a component. We can put it on our canvas, okay? Or we can double click on the canvas and type in our component, and we have a bunch of suggestions. We can also get access to components that way, okay? Now, so once we have our component on the canvas, let's talk about how to operate this thing, how to use it, okay? So first of all, we have this orange flag that might be a little bit alarming. It's not a big deal. Don't worry about it too much. We can solve this easily. Basically, what the orange flag is, I'll talk about the three different flags that we have going on here. So the orange flag is a runtime warning, okay? And if we right-click on the center, we can see our runtime warnings here, and there can be more than one, or we can click on the flag and see a runtime warning. And usually an orange runtime warning, usually a runtime warning, which is always orange, is telling us that we don't have enough data to calculate to operate the component, and not enough data to calculate or not enough data to perform anything. So we'll talk about how to put something into that component in 1 second. But let's talk about the other flags that we might run into. Okay, so we have this red flag here is a runtime error, which means that the component couldn't complete the calculation. And again, we can click on it and see our runtime error, or we can go into the menu and see the runtime errors there. Now, it's important to note that a runtime error won't perform any calculation. The calculation failed, but sometimes a component with a runtime warning will have a successful calculation. I do have some scripts where I have components with runtime warnings that in the script is working properly for several reasons. It's not necessarily good practice to. You should address it if possible, but sometimes it's not. Sometimes it's unavoidable. Okay, so just something to note. So you should address it, but it's sometimes the component will work properly, and it's giving you a warning for a specific reason that you may be able to ignore. Okay. Then it's not as common, but we have this gray flag, and it's actually called a runtime remark. Okay, and it's just telling us something that is important to note about the component. It's not necessarily telling us that there's any type of problem. Okay, in this case, it's telling us the sequence notation of this component. Okay, so those are the three flags that you'll run into. Okay, and since we're talking about colors and displays, so yeah, we know that if it's orange, it's a runtime warning. If it's red, it's a runtime error. If it's gray, there's no problem. If it's light gray, it's no problem, and the preview is on. And if it's dark gray, then the preview is off. And if it's faded gray, then it's not enabled. And we'll talk about that. I'll show you what all that stuff means in 1 second. Okay. So first let's talk about how we're going to get geometry into this parameter. Okay. This is a geometry parameter. Okay. So we need to get geometry into the parameter. We know that this is a point parameter. Each type of geometry has a different type of has a different parameter. And we can go in here. We can see that we have a point parameter, vector parameter, circle, plane, surface. Lots of different types of parameters for different types of geometry. So if we want to use a point, we're going to use a point parameter. Okay. So there's two ways to do this. Let's do the first way. So we can go in, set one point. So we right click in the center of the component. We went set one point, and I can grab a point in Rhino. So now it's referencing a point in the Rhino model. And if we move that point around in Rhino, the grasshopper component, the point component, will follow it. It's going to follow that reference point. Okay, and that same action will happen with any of these geometry parameters. So, but that's not the only way that we can drop geometry into this component. A different way to do it is not to reference anything in the Rhino model, but we can still use the Rhino viewport to view our geometry. And the way we do that is by doing set one point, and we can go up to here in the options. It will either let you click on the viewport already, or if you can't click on the viewport, you go up here, type equals point, click on that, and then actually go to coordinate. It's going to let you set up a coordinate instead of referencing a point. Okay, and now you can drop a coordinate wherever you want on the Rhino viewport. Okay, and now that we've dropped that point, this is actually internalized data. Okay, that's what we call internalized. And you'll notice that word is actually in the menu, and we'll talk about that in 1 minute. Okay, but now that we click on it, our point actually has this kind of gumball thing going on. Okay, and now we can drag this point around. And there's a few advantages to having internalized data. So this is not referencing a point in Rhino. Before we were referencing this point in Rhino. This is not referencing a point in Rhino. This is just we just have this sort of we have this coordinate that is the coordinate data that's in Grasshopper, and it's just plotting it in Rhino, and it's letting us grab onto it and move it around. So one of the advantages of this type of data, of internalized data, is that we can that the script will actually update live, and I can show you an example of that right here. Okay, let's first do let's reference a point in Rhino, and I'll show you what that looks like, and then I'll show you what it looks like when it's updating live with internalized data. Okay, so we'll set this point object. Okay, good. So our script is working, but let's see. This is an attractor point script, right? Very simple attractor point script that we're going to use in a later video. And if we move that around, it's going to update, and that's fine, but it's not updating live necessarily when I'm moving it. So it will update after I complete my transformation. But let's look at what it looks like if this data is internalized. Now we can either set one point and select a coordinate, or we can select a point already existing, and we can go to internalize data, and it's actually going to give us the exact same result as if we set a coordinate point. See, we have this gumball thing. So again, internalize data to an already existing point is going to give us the same result as setting a coordinate like we did in the last example. And you'll see now two things. You're going to see two things. Now it's updating live. Okay, it's updating the script live even before I stop moving. Also, it left behind this Rhino point. Okay, so it's not referencing this point anymore. This point has nothing to do with what's happening in Grasshopper. We can just delete that point. It has no effect. Okay, and we can still move this thing around. Okay, so again, we can clear this. We can either go in here. We can. It's already selected. We already have coordinates selected. We can either go in here and drop a coordinate. Okay. Or we can reference if it's already referencing a Rhino point, we can do it that way. Or we can take that reference point and go internalize data. Okay. There we go. So there's kind of three different methods that you can use to set up your parameter. Okay. Now the other advantage to internalize data is that it's saved in the Grasshopper file, not in the Rhino file. What that means is a few things. If you have a simple model and you don't need to reference anything in Rhino, you can save your Grasshopper file. You don't need any reference geometry in Rhino, so you don't actually have to save your Rhino file. And that means it's also easier to send scripts to other people because you don't need to send a Rhino file accompanying it, and it's easier to store your own files. But that being said, I almost always have a Rhino file associated with it because I want to be referencing my geometry. I want to be working in Rhino sometimes and referencing geometry in Grasshopper, so I'm taking advantage of some of the workflow advantages in Rhino and some of the benefits in Grasshopper. So I want to be working on both. So I almost never have a Grasshopper file where all my geometry is internalized, but I have done it, and it's pretty practical with simple scripts. Okay, but that's a preference. That's up to you. Okay, let's talk about some of the other. Let's talk about some of the other options in this menu. So I'll set up this curve parameter first. Let me just draw a curve here. Okay, we gotta do the same thing. Set one curve. Okay, cool. And I'm gonna hide this curve in Rhino. So we're only looking at it in Grasshopper, but we're still referencing that Rhino geometry. So you'll see that it's red when I'm not selecting it. It's gonna turn green when I am selecting it. Okay. Actually, yeah, let's use something bigger. Let's use a surface. not selecting it. It's green when we are when it is selected to show us what geometry this component is associated with. Okay, and we can preview it, or we can turn the preview off with this first menu icon. Okay, so now it's turned to darker gray, and that means that if this wasn't in Rhino, we wouldn't even see it at all. Okay, so it's gone. Okay, we can turn the preview back on. We have a preview, and we can disable it. Actually, that's the next item in the menu, and that just completely disables this whole component, and there's no data coming out of this component. Okay, so no data was collected. Okay, once we turn it back on, we have our reference surface again. So what else do we have going on here? Bake. Bake is the egg. The egg is how we it's how we transfer geometry from Grasshopper back into Rhino. All right. So if we take our geometry, we do some modifications, whatever. We've moved it now, and if we bake this, the little egg, it's gonna ask us what layer, and we've baked it, and we've placed that geometry back into Rhino on one of the layers, depending on which layer we chose in the attributes menu. Okay, so that's what the little egg is. You can bake any type of geometry, any type of component. Sorry, any component with geometry, you can bake it. Okay. What else we got? Let's get rid of this. Wire display. Okay, wire display. So if we have multiple points, we have. Let's get rid of this. I don't want that. If we have multiple points in our component, sorry, go to set multiple points, and okay, so if we have multiple points in our component, you can go to set multiple points, and you can plug in as many points as you want. So if we have multiple of anything in a component, that means that we have multiple lines of data. Okay, several. We have more than one list item. We have more than one items in a list. Okay, and we can see that with this wire. Okay, so that's what I wanted to bring up. We're looking at this wire display. Okay, it's a double line. So you'll notice that if there's only one geometry, then it's a single line. And if we have multiple geometry, we get this double line. Okay, and if our geometry is grafted, we actually get this dashed line. And I'm not going to get into grafting in this episode, but just something to note. That's what the dashed line means. It means we have grafted data. It means we have multiple branches and multiple lists of data. Okay, I'm going to be making more videos about that later. Okay, so what else we got here? We can disconnect from the menu. We can choose which one we want to disconnect. Oh, wire display. I had to cover that. Almost forgot wire display. So let's look at wire display. So we have our double line wire. We've got multiple items. We can change the visibility. This is purely a visibility setting. We can go to faint, and now we have this faint wire. And if we click on it, we can see the full wire. We can even push it further and go to hidden. We have this little Wi-Fi symbol. And when we click it, we can see the full wire. This is super useful if you have a really cluttered canvas with lots of components. If you have a complex array of components, turn some of them off. Helps clean up the appearance of your canvas, of your definition. All right. So that's what the display does. Okay. So and I don't know if I covered this before, but you connect it. You connect your wire with the left click and drag. You disconnect it with the control drag. And if you need to connect two, you connect to one, and then you hold shift, and then you have that plus icon. You can attach as many as you want, and then you disconnect it with the control key. Okay. So good. Here we go. What else we got in here? We covered These ones, all of these are called input-output modifiers, I/O modifiers. These are going to affect the input or output data stream, and I'm going to make an entirely separate video on these settings. And so check out that other video here. Okay. And down here, we already covered set one point, set multiple points. We can also manage the point collection here. You can see our different points. It will define those points. It will give any kind of information that's necessary to describe those points. And this is applicable to um, any type of geometry. It will be giving different information to those geometry. We can add and and delete different components of our geometry. Okay. So clear values, it's pretty obvious. It's just going to clear out that component back to kind of default without any data in it. And internalize data, we talked about that. Important thing to understand. And extract parameter. What that's doing basically is there's no point in using it for a parameter, but if we had so we can so we can set a point for a point or any type of geometry. Usually it's going to be a plane or something in a regular component. We can do something like that. We can set up a plane like this in this component, and we can extract that parameter into a parameter component. Okay, so I'll just do that one more time. We can set if this component needs information, we can go in here, set one plane, and that's basically our input data. But it's internal. It's inside this component, so we can extract that parameter and turn it into a parameter component. Okay, so that's what that one does. And the help, and the last one in the menu is the help, which is useful if you want a bit more detail, if you want to learn how it works, or you want some more details about that component. There's a lot of really good stuff in the help portion of this menu. All right. So we covered basically these menus. They're not going to always look the same. In future videos, I'll talk about some of the differences between. So there will be some differences in the menus. For a parameter, the menu looks the same no matter where you click it. But for most components, the menu does not look quite the same. We can go in the center, and we have only a few options relating to the main function of the component that we've already talked about. And if we right click on the input itself, we have also some of the other menu items that we've talked about, but we don't have all of them in one place like we do in the parameter component. Okay. So we basically covered the operation of the component. Not all of them necessarily going to be operating the same way, and I'll highlight a few of those differences, but there's really too much to cover in one video. So let's just talk about. I want to move on to different types of data streams. Okay, so we talked about the point, pretty fundamental. Points are points. We have a curve. I showed you a surface. So we have different types of geometry that that are going to exist in a data stream. So this is an example of a data stream. We have a point going to a circle, and then we can use a number slider to set up our. That's a different data stream. That's a number. Okay. So this is a number data stream. This is a point data stream, right, in the wire. Okay. But then we also have lots of other types of geometry. We have in here we have Boolean data, which is just true or false. It's going to either show up as true or false, or it's going to be 1 or 0. Okay. We have numbers. We have text, colors. Lots of file path. A file path is another type of data stream, not as common, but I'm just I'm just giving you the idea. I'm just showing you that there's different types of data that we're going to be using, and they're not, universal. They can't be interchanged necessarily. You need to understand what data is required from the input, and we talked about that in the last video, one of the previous videos. You need to understand what data is required. You need to understand what parameter or data input that you need to use to make that component work properly. Okay. And here's an example of an input component. Um, this is producing the same data as this parameter. So we have a Boolean parameter and we have a Boolean input component, which is called a Boolean toggle. So if we use the Boolean parameter, we can choose to set the Boolean to true or false. We can get the same data actually um, from this component. It's just a different way of it's just a different. The only difference is going to be the user interface. Okay, so we have different ways to control the user interface. This parameter is a bit more cumbersome, but it has some function. It's also smaller. But if we want to have easier access to that parameter, we can just use the Boolean toggle. Okay, but we have lots of different examples of that. If we want to have access to numbers, we can use either a number parameter like this, number parameter like this, or we can use a number slider. We can also type in numbers into a panel, but that's not always going to be a good idea because some components won't convert this this text um, this text character into a number. So it's best to stick to using a number slider or a number component. Um, okay, so yeah, so the slider is one way to come up with an input. We have lots of different input components here that you can explore: control knob, button, digital scroller, colors, okay, graph mapper, lots of stuff that we will definitely get into in later episodes. Okay, the panel, something that I use often. We can put text in here. Um, we can put numbers in here. We can put characters in here, depending on what we need it for. We can use this as an input, but we can also use it as an output, like I showed you here. We can see the output data in this panel, or we can use this um, to define a data input for another component. Okay. So again, for a panel, the easiest way to do that is to double click and hit the quotation mark, and then you'll open up a panel. You can either start typing like this. You can hit the quotation mark and start typing, or you can just hit a quotation mark and open it up like that. Okay. So those are the basic kind of different types of data streams. There are obviously I only touched on the basic types of data streams and input parameters and input components. Let's just take a look at some other types of components that we'll come across. Actually, there are a few more data streams that we haven't really talked about, types of data that we haven't really talked about. This is an example here. We have construct domain. So a domain is a data type that you're going to want to be familiar with for a lot of different types of designs. We have some, and I'm going to talk about the domain. Actually, I'll talk about the domain right now. So let's talk about. I have this script here that's gonna it'll be an example to show a domain, what a domain is, an introduction to domains. We'll talk a little bit about some Boolean operators. Okay, so let's put together this little script that I made here. So I have these circles made up with this script, and this populate 2D. Okay, so what do we got here? We have this outline, this curve. We have this populate 2D component placing some points. Again, I'm just doing an overview, so I'm not really going in depth here. We're definitely going to talk about these concepts in other videos, but I'll just briefly explain what's going on here so you can understand some different types of data. All right. So we have these populate 2D. We have these points. I'm going to turn that preview off. here's a domain, okay? So this is a good example. So we have these points acting as the plane for the circle. So each circle is being placed at each one of these points, all right? And we have to define also the radius of these circles. And I wanted to create a bunch of randomly sized circles, but random is not definitive enough. We have to define a range of random numbers. So that's what this is. It's a range. And you can see that little hexagon there. It's showing us that we need a domain to create that range. So we're going to use construct domain, and we have these number sliders going in 1 to 10. So that's why our domain is 1 to 10, okay? And that means that our random numbers are going to range from a radius of 1 to a radius of 10, okay? And if we change that, then our max is 5, our minimum is 1, our maximum is 5. You know, you get the deal. I know you get what's going on, okay? And but let's say, so that's what a domain, that's an example of a domain, okay? Definitely going to talk more about that in other videos. Let's say, so here's an example of using booleans, using a boolean operator, and this is, this is a math component, and we're doing a test. We're doing a test with numbers. We're going to get some boolean operators, and the reason I wanted to talk about this is just to show that there's some components that are only using boolean operators, okay? And I just want you to be aware of different types of mathematical concepts that we're going to be using. So here's an example. You know, let's say we already had this plot of circles in Rhino, and we want to select only a certain size of the circles. We only want to select a range of sizes. We don't want anything larger than a certain size, and we don't want anything smaller than a certain size, okay? So what we could do is set up this larger than and smaller than component. So I'm going to plug this radius into here, and which one does it go to? Yeah, this one's here, and then this one's here, so radius is larger than 1 and smaller than 5. Okay, and so what we're gonna do is now we have a test of testing each one of these circles, whether it's larger than and smaller than these two numbers, and we're gonna plug this into a gate and component. So we actually have two Boolean operators going into one component. So we're doing a test. We're basically testing it twice. Okay, and watch what happens if we preview what's coming out of here. Oops, did that wrong. Plug that into there. Okay, check this out. I have it previewed in white so you can really see what's going on. And what you can see is we're filtering out all the components except the ones that are between 7 and 8, or whatever we have these numbers at, okay? All right. So I know this is a little bit specific, but I'm just showing you that you might need to kind of get into like how to use Boolean operators and that type of thing if you want to achieve some really interesting stuff in Grasshopper. Okay. So here's another example. This is actually an example of list management. This is cull pattern. Okay. We're taking a list and then we're culling, which culling is basically meaning deleting. We're deleting certain points, certain items of the list depending on the Boolean values. Okay. Okay, let's keep going. Let's take a look at some other components. So we basically touched on some of the mathematical components, like in this category, we have the domains, we have the operators, like simple mathematic operators, and then we have some of our Boolean operators. We have other things like polynomials, scripting, trigonometry, okay? In the sets category, we have different ways to manage data. Okay, a list item will take an item out of a list depending on which index we use. We have, we already showed you the call pattern component. Okay, we have we can manipulate text data streams, and we also have kind of more complex components for tree management, data tree management. Okay, which we will talk about in one of the next videos. I'll give you a quick example of something like that. This is this is um, this is a clean tree which comes out of this comes out of here. Clean tree. This is an example where we're taking a complex data stream. Well, it's not that complex, and we're using clean tree to actually remove certain branches. Um, we have this data stream with empty branches. Okay, we're using clean tree to actually remove any empty branches. All right. Anyways, let's get back on topic. So different ways to manage data is basically the summary here. The next category, we have vectors. In the vectors category, you already saw populate 2D where we populated this rectangle with points. We can create planes. Okay, create different planes with lots of different components for planes. Those are very important. Create points. We can use and modify vectors for different translation components. Um, Translation components is just one example, but we use vectors for a lot of different things. Okay. The next category is curve, and so we have some primitive geometry that you're familiar with, like circles and rectangles, polygons, lines. We also have splines, spline geometry, which is like control point curves, NURBS curves, and stuff like that. Different curve modification components, and then we have some other components for analyzing curves that we'll definitely get into. Okay. The next one is the next category is surface. So we're looking at again we have a bit of a similar thing here as with curve. We have some primitive geometry, some more complex geometry, and some analysis tools for analyzing geometry, and then some other components in here for modifying geometry. Okay, some similar things going on in the mesh category with primitive meshes. Okay, we have the ability to create a mesh from a brep. We have analysis tools for deconstructing meshes and evaluating mesh edges and such. Okay. The intersect category is any type of intersection between different types of geometry. We have things like intersection between curves, between breps, between curves and breps, surface and curve. You can go through this. Lots of different types of intersections, and some trimming tools. You'll see that these solid components are similar to what we would call in Rhino our Boolean commands, like Boolean difference, Boolean split. That's what these are doing. Okay, and these are similar to the split components for surfaces. And the transform, these are a lot of familiar. I think you'll see a lot of familiar components in here, like the array tools and some simple transformations like move, mirror, and rotate. Obviously, these get used a lot. And we have some more complex transformation tools like sporf. That's a fun one. Sporf, twist. Okay. And the last native category to Grasshopper is the display category. And the main things that are going on here is like custom preview. That's an important one, where you can change the color of your preview or other properties to your preview. That's how I made these white. What I actually used to do this is I used custom preview line weights, which is actually a component in Human, not native to Grasshopper, but I just want to throw that out there because it's really useful. You can change the color, and you can actually change the line weight of the component of the objects, the geometry. Okay. Some other things that we can display is like a quick graph where you can graph your data. You wouldn't necessarily you wouldn't necessarily graph this, but I'll show you what that looks like for graph if we're graphing the diameter of these circles, something like that. We wouldn't really do that, but um, there you'll see an example of a quick graph in one of the future videos. The other thing that we can use, the other really helpful thing to display is a vector display, because a vector does not show up in Grasshopper automatically unless we use a vector display. And a perfect example of this, or one example of this is right here in this model, where we're creating this curve with a definition, and when we change our vector lengths, we can see a preview of what those vectors look like with this vector preview component, and we can see how that's affecting our curve. Okay, what does this thing look like? I'll turn this on for you guys if you're interested. I have this interesting vase thing for a workshop that I'm running. Okay. Anyways, okay, so we covered, just to come back, summarize this thing. We covered basically how we can get data into our components. We talked about the different menu items. We talked about internalizing data. We talked about different types of data streams. Geometry, Boolean values, colors, numbers, different types of data streams. We also talked about these warning flags, okay? And we talked about some of the wire display properties, and then we just went through the different categories and kind of reviewed the general, main components to be considering, okay? So I hope that was helpful as a introduction. Let me know what you guys think. In the next episode, we're going to talk about groups and clusters and user objects and other ways that other things that we can use to be a bit more efficient, especially with keeping our canvas legible, not too cluttered, and also with navigating the viewport, or navigating the canvas, I should say. Okay, so that's in the next episode. So I hope you learned something from this episode, and I'll see you guys in the next one. All right, welcome back to Grasshopper Fundamentals. I want to spend a few minutes talking about groups and clusters and user objects, and a few other tricks that we can use to navigate the viewport more efficiently, especially when we're getting to larger scripts. Okay, so first let's talk about grouping. Basically what all this stuff comes down to, what we're talking about in this video, it won't affect the functionality of the script. This is going to affect the efficiency at which we use the script. It's going to affect the clarity, the visual clarity of the user interface. It's going to affect the workflow and the ease of use of the definition. Okay, and so groups are only groups only have a visual property essentially, and what a group does is we can take a set of components, we can right click the canvas anywhere, and we can click group, and we put a box around it. Now why would we want to do that? Well, if our script is small enough, then this doesn't really matter. These are a few different variations of a similar form generation. Again, a script this big doesn't really matter. This starts to get a little bit bigger. When we get to this size or bigger, I like to start grouping things so that I can keep track of what parts of the script do what. And I want sort of a very easy visual cue. Okay, so if I take the whole thing and I group it, Now we can actually just grab the group and we can move the whole group at once. We can group, I'm going to group the output, and I can change the color of the group to help me sort of identify it faster. So it really helps when you change colors. Your brain will associate different colors to different parts of the script, and maybe even you can develop your own personal standard. Maybe your preview, maybe the last parts of the object, the final geometry in the preview or something. Maybe that's always red or something like that. It's up to you. It's up to you how you want to go about that. But grouping is a good way to visually identify parts of the script efficiently. So with the group, we can also change the sort of shape of it. I generally only use the rectangle personally, but some of these other shapes might be useful to you guys. And we can also use the group to select all the objects at once. This is especially helpful if it's a very large part of the definition. We can use these tools here to add and remove things from the group. Okay. And we can also make a new default color. Okay. So that's the extent of groups. Fundamentally, it's fairly simple. And we can kind of take this a step further and talk about clusters. So clusters are a little bit more complex. And there's a few different ways to approach developing a cluster. So we've grouped this together because it all kind of shares. I mean, everything that's happening here is coming out of one output. So this could be a good place to make a cluster. One more thing about groups. Speaking of, cluster has a similar property, but which would reminded me. Just one more thing about groups is that you can name this. So I'm going to call it like base geometry. This is especially useful if you have many different groups, a large definition, or if you're going to use this file a few weeks or months down the line. It's going to help you remember what this part of the group does, or what this group does. Okay, so we can do a similar thing with a cluster, but it's fundamentally, well, it's very different. Okay, let's get into it. There's a few different ways that we can approach a cluster, so I'm going to show you how that works. We can take, so a cluster takes all the components, basically just jams them into one user-made component. Okay, so put very simply, just take all these components, and I'm going to show you this is not necessarily what you want to do, but you can take all these components, and then we can right-click, we can cluster. Okay, and now we have all this stuff inside this cluster, so everything that you just saw. And what we can do here is we have a little preview. If we hover over it, we can enter the cluster. We can make our edits this way. And this component here is our cluster output. Okay, and then we can go to this box and we can save, discard, or just return. Okay. Now, but we had the problem here. I mean, this looks very nice. I mean, we really saved a lot of space on the canvas. We simplified it a lot, but we don't have access to the number sliders that used to be there. So I'm going to go ahead and undo what I just did. Okay, and I want to actually still have access to these number sliders. So I'm going to pull them out a little bit, and I'm going to grab only these components. So basically what I'm doing is you only want to cluster something if you're not going to be accessing it very regularly, or if your script is huge, you're going to have to make a lot of clusters anyways, and you're just going to have to get used to going in and out of clusters. But if you can, you're going to want to only you're going to limit how much you want to put into a cluster to only the objects that you're using the least. So I'm not really going to need to access these. I'm just going to use these sliders. And so I'm only going to put these into a cluster. Okay, so that's a little bit better. And now we still have our inputs, and we have a few of our outputs. And we can still go in here, but you'll notice that we have these are called cluster inputs. Okay, and but now you'll notice that So none of these are named. None of these are named. So if we might not know what they are doing, so we can change the name of these. But I don't really remember what this one does at this point. So I'm a little bit confused, right? So that's the one of the problems with this method of creating a cluster is I can't really remember what each one of these letters does. And I could look at it here and I go, well, okay, I know this is the number of points in the base curve. So I could change the name of this. I could change the name of this to uh, points in base curve. And I'm just going to leave the nickname. I'll just do the same thing. Points in base. Okay. You can add a description if you want. And so what I did was I just double clicked it to get into there. Okay. And if I go out, now it didn't show up on the, it didn't show up here, but it will show up if I, no, I guess it won't show up if I hover over it. So what I'm getting to is that there's a different way to make a cluster, and you know, it's not. I mean, there's a compromise. It might take a little bit longer, but you can label it all first and then make a cluster so that your labels are a bit more clear. Okay, and this is how we do it. Again, there's a compromise either way, so you're gonna have to decide the best way that you want to go about this. But this is generally how I do it because I like having my labels clear. If you don't mind that your labels, your input and your output labels aren't clear, then don't bother doing this because it's going to take a little bit longer. But I like the clarity of it. So what we can do in the param category in the utility, we can find the cluster input, or we can just type it in, input. Okay. And then we can actually just attach it just like this. And so this, I know that this is the diameter. And I'll call it diameter. We can just start naming all of these things manually. This is the number of points. Okay, plug that into here. And this is the same. Oh yeah, this is the same. Okay, I should have mentioned that before. This is the same input, but we actually had both the x and the d on the input of our cluster, which is not necessary. It's too messy. So I should have mentioned that you know, we only have 3 sliders, but we ended up having like 5 inputs, and it's because it was using a separate input for this one and this one, even though they were coming from the same slider. So this is also a better method to do for that reason, because we're gonna have less inputs. I'll show you what I mean instead of just saying it. Okay, let me show you what it looked like. Okay, so you see what I mean? We have 5 inputs, but we only have 3 sliders. These are redundant because this input is the same as this one. They're using the same input, so we don't need separate inputs in that cluster, which is why it might be better to build it the way that I was showing you. So let's get back to that, finish that off. Okay, so we can do our inputs. Our inputs are good, and we only need we only need 1 output. Okay, so we can go to here, and I don't need to label that because I know what it is. So let's take all of that. We have to include the cluster components and take all of that. We can create our cluster that way, and then we can plug in our sliders and drop it on there, and now we're good to go. So it's a lot cleaner. We have labels. We only have 3 inputs. We can still go in and make our modifications if we need to. Okay. Now you'll notice that the preview for the output is on, but the preview for everything else that's going on in here is not on, like the vector the vector display. If you do want that to be on, all you have to do is hover over it and go to preview contents. Then you can see it's going to preview everything that's being previewed in the cluster, but all this stuff is turned off, so it's only going to preview this stuff, basically, right? Only the things that are where the preview is on, okay? Oops. Okay, cool. And what else we got here? We have some other, we can set up different properties. We can name the cluster, a few different ways to name it. You know, and you can put in other information if you want to. Okay, so now when we hover over it, we can see the name that we've given it, and the description if we gave it a description. And if we turn off our icons, we can see that name here. And you can add an icon to this also. Oops, wrong one. You can add an icon here if you make an icon. I've done that a few times. It's like a 10 by 10 pixel image. I think it's 10 by 10 or 12 by 12 or no, I don't know what it is. 25 by 25. Anyways, you can look it up. Make a little icon in Photoshop or something, and you can add it to your cluster if you want to. You can also, do some other stuff. You can assign a password. You can export it. You can also explode it. It's not a super reliable way to go back. If you're not sure whether your cluster is going to work, I would maybe... I don't know. I would maybe save your original script before you start making clusters, because even once you explode it, it's not always going to go back to what it was before. This one worked pretty well. This one went back pretty well. Okay, and so the next thing we can do with the cluster is if we know that we're going to do this often. I don't think I would do it with this cluster, but if we're making a cluster that we think we're going to use often, is we can click on it and we can go to File and Create User Object, and it's actually going to save. So I'll call this a cluster test. It's actually going to save, and this is where we can add our icons and stuff. This is a good place to add an icon because we're going to save this into our user folder, our user category. Okay, so I've just saved it, and if we go to our user category, just disappeared. Here it is. Here it is, user category. We have our user saved clusters, so we can go and treat it like a component, basically. And so this is a good reason to add an icon, so you can identify it much more easily than the traditional the box. Okay. Oh, we also have these tools. I'll just mention quickly. We have these tools here where we can highlight a bunch of components, and we can align them. We can align them in certain ways. We can make them evenly spaced. Okay, space them out properly. That's another way to organize the canvas. But another thing that we can do that's a little bit different, we talked about specifically about cleaning up the components and cleaning up the canvas. But if we have a really big definition, one thing we can do to help us move around the definition is we can use this jump component here. So we'll add one jump over here. Let's say this is a big definition and we want to go between the graph mapper and this little area here, because let's say we are adjusting the shape, changing this, okay, whatever, and then we want to go to the graph mapper and change the shape of the profile of the revolution profile. Okay, if I double click this, it's gonna shoot me over to the other jump icon. Perfect. And now I can start modifying the graph mapper. Okay. Cool. So yeah, that's what I wanted to cover in this video. Hopefully, these methods help you sort of clean up your canvas, keep everything a little bit more organized, and help you move through your definition more efficiently. So I hope you learned something, hope you enjoyed, and I'll see you in the next video. I/O modifiers. What the heck are I/O modifiers? Not to worry. This video is going to cover everything you need to know about the basics of I/O modifiers, okay? So have some patience and sit back and relax and learn about I/O modifiers, okay? Input, output modifiers, all right? So we have our inputs and our outputs, and we can use these I/O modifiers, which reside in the menu. We can use these to modify the data that's coming in or going out of our components, okay? Now, oftentimes these modifiers are on the input, on the output, are the same, but not always. There's sometimes a certain extra modifier on the input or the output, okay? So we're going to go through sort of the standard list, and then we're going to look at some modifiers that come up less often, but are still very important. We're also going to look at some components that actually do a very similar job to I/O modifiers, okay? And we can kind of use those as a reference point to help us understand these I/O modifiers, okay? And then we're also going to go through a few examples of each modifier, each main modifier, okay? So let's get started. First of all, we have this kind of standard list. Now, there's no real kind of standard modifier list, but this is the list that will show up most often. So I'm kind of calling it a standard list. All right, these are the most common modifiers. So we have principal, reverse, flatten, graft, simplify. These are all affecting the data structure in some way. And I'm going to explain, I'll show you that in the demo below. And we have the same modifiers on the output. This is the extrude component, you know, it's a basic component. And I've actually put it on here twice because if you look in the direction input, we actually have 2 extra I/O modifiers. And we have unitize and expression. So first of all, expression is going to show up almost any time that we have a number input, some type of input with a number or a vector or something with some type of number associated with it. We're going to have an expression I/O modifier. And what we can do with the expression modifier is we can type in some type of mathematical expression that will affect the input or the output. So x is the value that's coming to the input, and then we can put any type of mathematical expression. X times 2, x divided by 2, plus 4, whatever. So this is super useful. I use this all the time, and you're going to see it in a lot of my videos. So what is the unitize modifier? The unitize modifier is all it's doing is, because this is a vector input, a unit vector is a vector of 1 unit length. So a unit vector would be a vector with a defined direction, but the amplitude would be a unit of 1. And if you put in a bunch of vectors, or just if you put one vector or multiple vectors into this input, the unitize I/O modifier will convert all the vectors into unit vectors, so single unit vectors, okay? Or it will be if you're combining vectors into if you're adding or multiplying vectors, it will still convert the final vector into a unit vector. Okay, what else do we have here? Again, I will go through these I/O modifiers, but they're a little bit. I don't really want to try to explain it. I'd rather show it in the demo, so I'm just going to briefly go over these other modifiers, and then we can go through the demos, okay? The demonstrations. So a degrees modifier is pretty straightforward. Any input that requires an angle number, an angle value, is going to have a degrees modifier. And the reason for that is because by default, all of the components are working in radians. By default, the program basically operates in radians. So if you want to work in degrees, you kind of just select degrees to change your preference to working in degrees. Okay, and we can see that here. So we're actually that's what this component does. Converts from radians to degrees, and it's doing the same job. Okay, so if we were to measure like a vector or something, if we were to measure the angle of this vector, it's going to give us uh, our number in radians. See, it says in brackets in radians. So we could actually change. We can't change the output here, so we would have to change the input to degrees. Sorry, what I mean is this is in radians, so you leave it as radians. But if you had a different input, if you were using a number slider and you wanted to use degrees, then if you want this to be 100 degrees and not 100 radians, then you change it to degrees. Okay. So the re-parameterize modifier. Ooh, okay, I almost tripped up on that word. Got it. Yes. So the re-parameterize modifier, what it's doing is it's changing the domain of a curve. This will always show up when you have a curve as an input or a surface. And it's changing the domain of the curve or surface to 0 to 1. Pretty straightforward. I'll show you that in the demonstration. Okay. Invert multiplier is changing the Boolean value. It's just flipping it. If it's true, it's going to be false. And if it's false, it's true. And it will do that no matter how many items are in the list. It's going to change all of them. It's going to flip all of them. It's going to invert. And so another thing to note is that any of these math components, they don't have an expression modifier, which, to be honest, I wish they did have an expression modifier, but I understand why they don't, because if you're going to put an expression into a math modifier, a math component, you might as well just use an expression component right here. So if you wanted to add, if I wanted to go x plus x divided by 2 times b, if it was a divided by 2 times b, I could just use an expression and I can add more inputs and just use the expression component to do that. Okay, so like I said, most components with a number input, like for example this angle, it's gonna have an expression modifier, but not these math components. They don't have it. Okay, it's not a big deal. So let's take a look at some demonstrations. So we'll start with principal. Okay, so principal is that first IO modifier in the list of standard modifiers. I don't have. Oh, do I have a? Okay, this is the example. Here we go. So let's say this is like a plot of ground. This B-rep is a plot of ground. We have these tiles, and we want to kind of spread some patches of grass or patches of flowers onto this grass. What we can do is create a 2D random distribution of 2D points, and we can project those points onto that B-rep. Now, some of them are going to miss, right? Some of them are not going to hit that surface when we go to project. And what that means is we're going to end up with empty branches. We have lots of null branches because any place where a point missed, we have an empty branch. Okay. After we've grafted this. Okay. We'll talk about that. We've grafted this data. Now we have these empty branches. And maybe the reason we grafted it maybe is because we want each point to be in a separate list, because maybe we want each point to maybe we want to multiply these points and create sort of a patch of flowers or something like that. So we want the list, we want each point to be in a separate list so we can kind of operate on them separately, right? So we've grafted it, and we have the dash line, meaning that it's grafted data, but now we have these empty lists, these null items, and we're gonna take the clean tree component to clean this up. And what we've done here is we've said remove null items from the tree, true. What else do we have? Remove invalid, remove empty items, empty branches, that is. And what we're left with is this. And if you look closely, you'll see that we have missing branches 0, 1, 2, 3, 4, 5, 6. So 3, 4, 5 is missing, right? So 3, 4, 5 is missing because this clean tree component removed those branches where we had these null items. See, 3, 4, 5. It just removed them, but it saved the path structure. Okay, and maybe that's important. Maybe we need to save the path structure for something that we're doing later on. Maybe we need to save that information. And up here, and so I'll get back to that in 1 second. Let's take a look at this is the principal IO modifier here. So we'll get to that in 1 minute. What's happening here is we have these random circles, these random radius circles, and we've also grafted it. So we have a bunch of circles of random diameters, random radii from 1 to 10. Okay, and we have the same number of them, of circles, as we do points, because we want completely different circles. So we have this list, but this list is actually, it has the same number of branches. Okay, 67 branches, 67 branches coming from this clean tree component. So we have 67 points, and we have 67 circles. So it has the same number of branches, but if we look at the last index number,